Number 11, more than halfway through now. Right, what does it say? Just integrate this. Right, well, just remember that, to leave that coefficient alone. That's the same as a sixth of, it's only the x goes up to the negative 2 dx. Then you add 1 to the power. Negative 2 climbs up 1 to negative 1. Divide by that new power, only has the effect of making this thing negative, plus c. So negative a sixth, x to negative 1 plus c, d. Number 12. What's the maximum value of this? Well, sine can only go up and down 1. So 3 sine can only go up and down 3. So if you're starting at 2, the highest you're going to get to is going to be 2 plus 3. So the maximum value is going to be 5. But it happens in the opposite order. Notice that's a minus 3. If you were to draw that graph, we'll just ignore that displacement for just now. 3 sine x should go up and down. So negative 3 sine x is going upside down. But shift it up 2. Means it's going to be going up and down 3 about the line y equals 2. So from that point it's going to go down 3 and up 3. I've not put the axis in, it's been shifted forward 3, so the axis is actually back here. And that would carry on back a bit. But the point is, that's going to go up to 5. But when does it happen? Well, that will happen even without considering a graph, so I'll just rub this out, because I'll just use it from this alone. You would get to 5 when the sine was equal to, or I'll put the whole thing in, when the sine of x minus pi upon 3 equaled negative 1. That part would have to be negative 1 for that part there to be plus 3. And the sine, the ordinary sine, is negative 1 at 270, which is 3 pi upon 2. So that's going to happen when the angle is 3 pi upon 2. Which means x is going to have to be 3 pi upon 2 plus pi upon 3. I'll just add them all up into sixths. So it'll be 3 times that is 9 pi, and that'll be plus 2 pi. So it'll have to be 11 pi upon 6. So the two together. 5 and 11 pi upon 6 is b. Question 13, what's the equation of this parabola? Well, you've already got the features of it that you would have got by factorising, so I'll just go back to the factorisation that would have produced it. There might have been a common factor, but negative 2 as a root would have come from the factor x plus 2. Negative 1 for a root would have come from the factor x plus 1. So that probably knocks out a couple of them straight away. It does indeed. And then as far as k, I could try answers into it, and I could just use this point here. When x is 0, y is 6. 6 would be k times, of course when x is 0 it will just be 2 times 1. So it says 3k equals 6, so k equals 3. So look for the answer that's got a 3 and a pluses, d. So question 14, integrating a function of a linear function. The inside's like the equation of a line, so that's fine. So it's just like integrating anything else just with a power. Add 1 to the power, divide by that power. Better still, multiply by its reciprocal. What was inside? 2x minus 1. What's its derivative? If you were differentiating, you'd have multiplied by it. You're integrating, divide by it. Divide by 2, well, that's the same as a half times it, plus c. And that'll just cancel out to 1/3 of 2x minus 1 to the 3 upon 2 plus c. So which one's that? 1/3, let's make sure you pick out the right one, a. 14a. 15. U is meant to be a unit vector. That's why it's some multiple of this, because this vector doesn't have length 1. A unit vector is length 1. So what's the length of this vector? Hasn't really got a name. Let's put this down. What's the length of this vector? Well, it'll be the square root of 3 squared plus negative 1 squared plus 0 squared. 9 and 1, 10. It's of length root 10. That's to be of length 1. So I'll need to divide that by root 10. So it's going to be 1 over root 10 times 310. In other words, k is 1 upon root 10, which is answer D. Number 16, this time the equation's got a trig term in it, and more significantly a function of a function that actually needs highlighting just to be safer. That's the same as cos x to the power 4. So when you differentiate it, well, the 3 is just a constant, you differentiate any other power 4, multiply by the power, 4 3s are 12, take 1 off the power, it drops to 3, but what was inside? it was a cos x. So multiply by the derivative of the inside, which is a negative sine x. Bringing that to the front, negative 12 sine x cos, I'll pop that back in, cos cubed x. So which one's that? C. Question 17. Scalar product, what's the value of a dot b? Well, I'll be using lengths in this one. The length of that, you can see straight away, 3, 4, 5. You could write it out. The length of a is going to be the square root of 3 squared plus 4 squared plus 0 squared. 9 plus 16 plus 0, 25, which is 5. So splitting that up, I've got a dot a plus a dot b equals 7. Now a goes in exactly the same direction as a. So it'll be all of a is 5 times all of a is 5. So that's going to come to 25. So 25 plus the thing I don't know is 7. So the thing I don't know, scalar product of a and b will be 7. Take away 25, which is negative 18, which is D. Number 18. What's happening in number 18 here? There's a graph drawn here. It says it's got stationary points at 0p and qr, and here's two statements. Multiple selections. You just have to put yes or no for each of these. First one says this. F of x, that means its actual values, its y coordinates, are less than 0. That's the wee negative bit there. It says between t and s, yes. It's less than 0, yes. Next bit. F dashed x is less than 0. That means the gradient, so it's heading downwards. It says it's heading downwards for x less than q. That splits it there. For x less than q. You're tempted to say yes, but no. It doesn't say less than or equal to 0. It says less than 0. But there's a discrepancy here. That's a stationary point, a falling point of inflection. It's momentarily equal to 0 there. So strictly speaking, that's false. Which means that the answer to that is 1 only, which is B. Right, 19, a quadratic inequation. Now you could factorise it that way to find the roots if you wanted, and then consider the graph, because that's an upside down one. So where does it cut? And to be less than 0, it's going to be on either side of that. I prefer it just to rearrange it. Just multiply them by negative 1. So I'll have x squared plus x minus 6, reverse that as well, greater than 0, because that's a good deal easier to factorise. X, 2, 3, the plus goes to the bigger one, they're opposite. Now, I can't write x minus 2 is greater, you certainly don't do that. I'm only factorising it for the sake of finding where the graph of that, now it's this graph I'm considering now, where the graph of that, and that's a positive one, cuts the x-axis, because it's the x-axis that separates the positives from the negatives. When is it above, when is it below? Well, one of the answers is 2, one of the answers is negative 3, and the one I'm choosing has got a positive x, and I've selected to be greater than 0. So that means I want the x is here, and the x is there. I want x to be greater than 2, and I want x to be less than negative 3, in order for this expression to be greater than 0, which is equivalent to the other one, the upside down one being less than 0. So that would give me, what's the answers? X is greater than 2, where is it? B. Last one, number 20, simplify that, we should notice straight away, that's the square of that. Rewrite it like that to make it more obvious. That's 3a squared over log of b of 3a. And then take that to the front. So I've got 2 log b of 3a over log b of 3a. Oh, why did I close that over? Which means that that just cancels out and gives me the answer 2. Oh, where is it? A.